transformation rules, and we're going to revisit them, I should say, because we did these in Algebra 2. And I'm going to add just a little bit in here of what I remember a couple of my students doing last year that helped them figure out things. So I hope that that can help you as well. But the first function, y equals negative f of x, if you wanted to look at an example to identify what had happened, you could look at the parent function, the square root of x, and then what happens to the square root of x when we put a negative in front of it. So I'm not going to spend my time doing that right now, but does anybody remember what happens when we put a negative in front of the function? What happens to our function? It reflects over the x-axis. And when I look at this, what I found helped some people last year is I'm always talking about where is the negative? Is it inside the function or is it outside the function? And before I really refer back to that, if you look at the second value here, y equals f of negative x, if the negative here reflects over the x, you can probably make a good hypothesis of what happens when the negative is inside the function. It would reflect over the y-axis. But in terms of where the negative is on these first two, the negative for y equals negative f of x is outside. And I don't know, like I said, I know that some people last year wrote that down on their notes and they found that to be helpful. And then the negative on the second one, it's inside the function. So that may or may not help you. But when we go to the next four here, f of x plus c. Again, off to the side, we have an example. We could graph the function y equals the square root of x, and then we could add 2 to it. Anybody remember what adding something to the function does? Grace? It goes up, and in this case I'm going to put up c units because we've got f of x plus c. Well, if plus c moves our graph up c units, what do you think minus c does? Again, you can make a logical assumption that we move down c units. And the plus c and the minus c are outside the function. The function's f of x, and then we're adding something to it. Or it's f of x, and then we're subtracting to it. Subtracting. These are outside of the function. In contrast, then, we've got f of x plus c. Well, look here. Let's look at the picture then. If we do the square root of x, which is our parent function here, on the wrong line, but then we do the square root of x, and then plus 2, what we're looking at is what happened. So there's the original, and what happened? We moved up. And that's what you can look at there if you need to with the calculator. And those, when we add c to the function or subtract c to the function, those are outside. But we can also do the inside of the function. We can do x plus c within the function. Anybody remember this one? And that's the question. Is it right or left? And what we're going to do is we are going to go left c units. It goes the opposite way of what we think it does for the inside. That's where the plus c is. But once we've got that down, then f of x minus c means that we're going to go right c units. And I hope that this is looking familiar for you. So, and it depends on who your teacher was. And then I know she did. So before I forget here, this is also inside the function. So then there's just a couple more. The next one's y equals c times f of x. And again, c is outside of the function. The function's f of x, and then we're multiplying the function by c. Do you remember what that c, in this case, does to our function? Do you remember, Claire? Okay. It's going to be a vertical stretch. And the thing that you have to watch out for on this one, besides the fact that this is outside of the function, is that c needs to be greater than 1. It can still be a fraction, but it needs to be greater than 1 for us to have a vertical stretch. Its counterpart, when we still have c outside the function, but c is some sort of fraction, and it's some sort of fraction between 0 and 1, we call that a vertical compression. Now, it just depends on your teacher. Sometimes your teacher called it a shrink. I'm okay with shrink, but really the technical term is compression. And, but I don't want to change the terminology from your previous teacher. I've been really trying hard the last couple years to do compression, so I think that I'm pretty good with that. But that c again is outside the function. But the thing about it is between 0 and 1. So that only leaves one kind of transformation left, because we've done right, left, up, down. We've done stretch and compress vertically. So that leaves stretch and compress horizontally for our last two. We have done the reflections as well, but the c is on the inside of the function this time. And to figure out what happens here is it says take the reciprocal of the coefficient. So for instance, if we took the reciprocal of 2, we would end up with 1/2. And then decide whether it's a stretch or a shrink. So I wasn't as good with the compression idea there. But when we take the reciprocal of 2, we get 1/2, which means that this one would be a horizontal compression. And that's inside the function, so it's when our value of c is greater than 1. But if we happen to have a fraction already, like we do on our last example here in our chart, we know that this is still going to be a horizontal. We can probably guess that it's going to be stretch. But once again, what we do to determine that is we take the reciprocal of, in this case, the 1/3. Reciprocal means that we're going to flip that fraction, so it would become 3/1. And that means then we would have a horizontal stretch by a factor of 3 if you're looking at the square root function. But in other words, sometimes the way that I think of it is that what happens inside the function works the opposite way of what you think it's going to. We had 2 inside the function and we compress. We had a fraction inside the function and it actually stretches the function. But there's your chart there, and it really, if you have a chart from Algebra 2 that you remember, this is still the same chart, same order. We might have written it a little bit simpler last year in Algebra 2, but it's the same chart. So what you might want to do is leave your chart out on your desk, and then as we flip this chart over and we look at the back here, that way you can look at your chart to compare back or to be able to answer the questions here that we're going to finish with here in our notes today. So when we look at this, for the following functions, we're going to identify the parent function, list any transformations that occur to the parent function. So the first one here, hopefully we recognize, is that our parent function is g of x equals the greatest integer of x, with the 2 brackets. But then when we deal with what's happening to these functions, these transformations, how do these values change our graph? We don't change the general shape of it, but we do different things to it. And there's actually 4 things that are happening in this function. The first thing that's happening is that negative out in front of the function. What does the negative that's outside of the function do to the function? It's the very first one. We're going to reflect. So it's going to turn the graph over. Reflect over the x-axis. Now notice, I only wrote the negative, and the negative that I'm looking for is right here. The next part is the 4. So the negative is separate from the 4 in terms of what's happening to the function. The 4 is still outside the function. What does it do to the function? It vertically stretches. And in general, I read these graphs left to right, which is a good way to do these. The next change or transformation in here occurs, it says x minus 3. So we're looking at the minus 3 here. Minus 3 is inside the function. What direction do we move when we're inside the function with this minus? We're going to move right 3 units. And one last transformation. The very last piece of our function is the plus 1. Plus 1 is outside of our function. How are we moving? Up 1. Now, just because you did this last year doesn't mean that you don't have to study this again this year. It took studying last year to understand it. It's still probably going to take studying this year to understand it. And that's okay. But that's what we're doing for our notes today, is we're practicing applying our chart here to these different functions. So the first thing that we have to identify here is our parent function. And it is the square root of x. And in this particular case, there's 3 transformations that are occurring to our graph. And the first one is coming from the 9/4. What does the 9/4, which is outside of the function, do to the function? Abby? It is vertical. but it's actually a stretch. And the reason that it's a stretch is because 9/4 is bigger than 1. Easy mistake to make. But 9/4 is 2.25 if you want the decimal. It's 2 1/4 if you prefer. But it's a bigger number than 1. So it's going to be a vertical stretch. The next transformation is going to come from this negative, which is inside the function. When the negative is inside the function, what happens? We reflect over the y. It's the second one on the chart. I should have labeled those in terms of 1s and 2, but it's the very second one on the chart on the front, or on your other paper. The last part on this one is that we have -6. How does that -6 change our function? We're going to go down 6. So far, so good. Hopefully, this is review. So when we look at the next two, some functions that we haven't had as much experience with, but we do want to identify our parent functions. And our parent function on number 3 is 1 over x squared. And we've got some things happening here, some transformations occurring in here. And the first thing, for lack of better words, that I see is that there is a negative right out in front of that function. What does this negative do to our function when it's outside of the function? We reflect over the x-axis. But here, when I write this next part, I'm just going to write it the way that I think of it in terms of identifying, because sometimes this one's a little bit harder to recognize. But when I think of this equation, I think of it as -1/2 times 1 over x plus 5 squared. And that might be a little bit easier to see now in terms of the 1/2. It's in that equation. I think when I write it here, you see where it comes from. So what would a 1/2 outside, so to speak, of the function do to the function? So it's just the 1/2. It's going to be vertical, stretch or compress. It's going to be compression. So now we have this x plus 5. The plus 5 is inside the function. When it's inside the function, so when we have the plus 5, how does it move? We're going to go left. And you don't have to write units. I don't know why I wrote that. So on problem number 4 here, again, what we want to come up with are the transformations that are occurring to this function. Again, e to the x, we don't have a lot of experience with e to the x, but I give it away there. Our parent function is e to the x. And in this particular case, let's look at this. I know our ultimate goal is to be able to do these without a calculator, but let's look at what happens. And actually, we don't need to look at everything that happens. What does the 3, which is outside of the function, do to the function? And hopefully you recognize that the 3 is a vertical stretch. But what I struggled with on this one was the 2 in the exponent. What did that 2 in our exponent do to our function? And, so what I did for the 2 here is I thought that it might be helpful. I mean, we do have a graphing calculator. Let's look at the picture and see if we can figure out what it actually does do. So if we come back up here and we say, well, here's e to the x. And I don't need to put the 3 in there because we know what the 3 does. It's what does that 2 do? So if we go second e to the x to the 2x, and we graph this. So here's our e to the x function. What do you think that 2 did for our function? Because we started here, and then we went in. We actually horizontally compressed that. Again, I think I can make the calculator do it. Well, I know I can do this. So if I clear that, and then I go second e to the x. Here's our first function, and then there's our second one. See how the horizontal, the red graph just came in a little bit? Hopefully. But there's that last one. So finally, to finish here, what we want to do is we want to go the other direction. We're going to be given the parent function, and we want to write down the equation of the function. So first of all, we have f of x equals natural log of x. So I'm going to write down the function, but I left a little bit of space in case we need anything in front of the natural log of x. And then we've got some space for some other stuff here. And it says shifted up 2 units. Well, if we shift up 2 units, at the very end of our function, it's going to be plus 2. And up is an outside of the function. But we also have a shifted right in here. That's an inside of the function. Remember, when it's inside, it kind of works the opposite way that you think it's going to do. So it's going to be subtract 7. And then the last part about this is it says that we're going to reflect about the x-axis. Well, where are we going to put that negative? Are we going to put it inside the function or outside the function? And it's going to be outside. So there's our function. Given that information, we had to write it. So let's try the next one. Our parent function's h of x equals x cubed. So h of x equals x cubed. I'm going to leave a little bit of space here. And actually, I might have to erase a little bit. So it says vertically compressed by 2/3. Where's that 2/3 going to go? It's going to go right out there in front of the function. There's the vertical compressed. This time it says that we're going to reflect it about the y-axis. Is that inside or outside of the function? It's actually inside. We're going to put a negative in there, but that's where I have to erase there, but it's going to be 2/3. I'm going to actually erase everything and try to write it neater. 2/3 times negative x. And then it says it's horizontally stretched by 5. Well, the horizontal stretch or compress is on the inside of the function, so I'm not doing very well in terms of erasing, because I need to erase. If it's horizontally stretched by 5, remember that we need to take the reciprocal of 5, which is 1/5, that's the horizontal stretched part of the function. And then we can get our cubic function there. 2/3, vertically compressed, negative, reflects about the loft. Horizontal stretch by a factor of 5 is the 1/5. And lastly, parent function b to the x equals 1 over x. I don't know if I even dare write the function down yet, but I guess we will. B to the x equals, I'm going to put the 1 over x here. And first of all, it says vertically stretched. Well, I write the 7/2 outside of it. So it's a personal preference. The 7/2 times that. It says shifted left 3 units. Well, if you look back up there at problem number 3 that we did earlier, we saw that we moved left 5. So this is going to be plus 3 in the denominator. And then to finish, down 4 units. That's going to be an outside of the function. We're going to subtract 4.